So, hi guys, I am Bryan Cabasag. I'm a second year student of BS Mathematics. So today I will discuss to you the section 4.3 entitled More Discrete Probability Distributions. So in this topic, I am going to explain to you in finding the probabilities using the geometric distribution and also the Poisson distribution. So, a geometric distribution, it is a discrete probability distribution and it must satisfy the following condition. First is a trial is repeated until a success occurs. Second, the repeated trials are independent of each other. Third, the probability of success P is constant for each trial. And lastly, the random variable x represents the number of the trial in which the first success occurs. So the probability that the first success will occur in trial x is P of x is equal to P of q raised to the power of x minus 1, where q is equal to 1 minus p. So here is an example for using the geometric distribution. So a study found that the smartphones made by a certain manufacturer had a failure rate of 42%. Four smartphones made by this manufacturer are selected at random. And then find the probability that the fourth smartphone is the first one to have a failure. So the solution is, given the value of P is equal to 0.43, and then the value for Q is equal to 0.57, and then the X is equal to 4, because we're trying to find the fourth smartphone. So P of 4 is equal to 0.43 times the 0.57, the Q 0.57 raised to the power of 4 minus 1. And now we're going to subtract the power. So 0.43 times the what? 0.57. So 4 minus 1 is 3. So the answer is 0.080. So therefore, the probability that the fourth smartphone is the first one to have a failure is about 0.080. Okay, next. So a Poisson distribution. So it is a discrete probability distribution and must satisfy the following conditions. First, the experiment consists of counting the number of times an event x occurs in a given interval. The interval can be an interval of time, area, or a volume. Second, the probability of the event occurring is the same for each interval. And lastly, the number of occurrences in one interval is independent of the number of occurrences in other intervals. Poisson distribution. The probability of exactly x occurrences in an interval is P of x is equal to mu power of x e to the power of negative mu over x rotation, where e is equal to 2.71818 and mu is the mean number of occurrences. Okay, so here is an example of Poisson distribution. So, the mean number of accidents per month at a certain intersection is 3. So, what is the probability that in any given month 4 accidents will occur at this intersection? So, given the value of x, which is equal to 4, and the value of mu, which is the 3. So, P of 4 is equal to the value of mu, which is 3 raised to the power of x, which is 4 times, so multiply to e, with its value of e is 2.71828 raised to the power of negative 3 over 4 notation. So, in solving this using the calculator, the answer would be 0.168. So, therefore, the probability that in any given month 4 accidents will occur at this intersection is 0.168. Okay, so let's proceed on the second example. Finding a Poisson probability using a table. So, a population count shows that the average number of rabbits per acre living in a field is 3.6. Use a table to find the probability that 7 rabbits are found on any given acre of the field. So, a portion of table 3 in appendix B is shown here. So, using the distribution for mu is equal to 3.6 and x is equal to 7, you can find the Poisson probability as shown by the highlighted areas in the table, so which is 0.0425. And now, let's find out if we can find same answer using the formula. So, the given value of x is equal to 7 and the mu is equal to 3.6. Oh, so 3.6 na siya. P of 7 is equal to mu, which is 3.6 raised to the power of 7 times 2.71828 to the power of negative 3.6 over the 7 notation. So, using our calculator once again, the answer is 0.0425. So, to the table, the probability is 0.0425. And using the formula of Poisson probability, we found out the answer is 0.0425. So, therefore, there are same value found using the table and the formula. So, okay, that's all for today. I really hope you have something to learn to my today's discussion in finding the probability using the geometric distribution and also the Poisson distribution. So keep safe and God bless.